Hey, did you know that the first thing on this recording is Jackson saying, "I don't care if my life's wasted"? Hello, people who are watching this. Enjoy. It's been a fun class so far. Emma just reminded me that I'm supposed to record this for you, so let's all say thank you to Emma. All right. So today we're doing something called Xbox problems. It is a problem that you do when you have a problem that is like a trinomial like this, but in front of this, whatever the variable is squared, there's not a 1 or, nothing, but it doesn't mean 0, right? If there's nothing, it means a 1. So far, you draw an X and a box. This is the original problem right here, 2x squared plus 3x minus 9. We're trying to factor it. The first step, which everybody should be paying attention to now, because just in case you missed it, the first step, the top left corner goes that first thing. Bottom right corner goes that last one. How did we get this one again? Right, you multiply number 1 and 2. Maybe I'll write that right here. Number 1 times number 2, just so that you remember. Circles around. Number 1 times number 2 equals number 3. You multiply them together. Look, we made it. Did you know that, just so that you guys know at home, that Tanner thinks this is a big waste of time. And that I wasted a whole 1 minute of his life. Look, do you hear how outraged he is? He's outraged right now about it. Not about me lying about him. Okay, the bottom number is that middle number, that 3x. All right, so now we're trying to find two numbers that multiply to get negative 18x squared, but add to get 3x. And remember, if I'm going too fast for you at home, just pause the video. You are capable of that. Anybody think of two things that multiply to get negative 18 but add to get 3? Yeah? Crystal? Tell me.
6x and negative 3x?
Yeah, so if you take 6x and you multiply it by negative 3x, do you guys see how you would get negative 18x squared, but they would add to get 3x? Yeah. Okay, so I'm going to put a step 5 next to both of those at the same time because you kind of think of them at once. I'm also going to put a step 5 over here because this is where they go. And it doesn't matter which one you put where. So I'll put 6x up here, negative 3x down there. And now we have to figure out what goes on the outside. So we're trying to figure out what comes out. All right, so look at this. Look, everybody look up. What comes out of 2x squared and negative 3x? An x. All right, so I'm going to put an x up there. What comes out of 2x squared and 6x? I'll put a 2x over here. Let's see, what do we still need? We have 2x, but we're trying to get to 6x, so what are we missing? A 3. We're trying to get to negative 9. We already have a positive 3, so what do we need? A negative 3, and that is your answer. X plus 3 and 2x minus 3. So I guess step 6 is just figuring out what goes on the outside and then rewriting it over here. Now, a problem like this, where we knew, remember from the beginning I said it's going to be 2x and x, and it's two things that multiply to get negative 9. There's only like 1 and 9, 3 and 3 that were options, but one had to be negative. So really, when it comes to like trying out different things, you probably could have done that one faster, the old method with Thorson's method, right? But as soon as these problems start getting complicated, like if the first number was 12x squared, that could be 1 and 12, it could be 2 and 6, it could be 3 and 4. If it starts getting negative, who knows where the negative is, right? And if the second one has a lot of combinations too, this is guaranteed to give you the correct answer always. If we multiply this out, we'll get right back to there. And the reason why this works is because basically we're moving backwards. Remember how before when we were multiplying, we started on the outside and then we filled in the inside? This time we filled in the inside because this one has to go there, this one has to go there, and these two combined made that third one. Anybody want an explanation about why we had to multiply those two to get this top number, like why that works? Anybody care? Okay, so this is just theory, and I'm never gonna test you on this, so just put your pencils down and pay attention, okay? All right, let's say I had A plus B and C plus D. This is just theory, okay? And I'm just making them letters so that it works for anything. This is AC, this is BC, this is AD, and this is BD. Do you see it?
Yeah.
Okay, now if I multiply these together, what if I multiply A times C times B times D? What do I get? ABCD, right? Or ACBD, however you want to say it. I'd get ABCD. What if I multiply these together? ABCD, same thing. That always works out that way, where this matches that. So this matches this. Do you see how this is negative 18 and this is negative 18?
Yeah.
And over here, what I'm saying is, I know that they have to multiply to get negative 18, and I know they have to add to 3x, and then I had to think of two things that made that work. So it's because of that relationship that we can do this type of problem. Again, I'm not going to ask you exactly why this works, but that's why it works. Okay. Do you want to do another one with me, or do you want to do one with your partner to see what you remember? All right, let's try. Do you want a hard one or an easy one?
If we do a hard one, can we get a hard?
How about we do an easy one first for a prize, and then a hard one for a prize?
Okay, deal.
Okay. All right, let's do. I need to grab my answer key and make sure that I have answers for these. Then none of them are not factorable, because I'm going to feel pretty bad if I give you one and you'll be like, but I don't know how to do it. And I'll be like, that's because you can't. Sorry. All right, let's do this one. 2n squared plus 5n plus 2. And for right now, hey, look at me. Is anybody thinking right now, I might just take Thorson's way and keep the parentheses and just think it out in my head? And if that's the case, you feel free to do that, but right now, learn the Xbox method, and then during your homework, if you want to completely disregard the thing I tell you, that's fine. So make an X, make a box, talk to your partner, go.
It's 4 and 5.
Oh, it's just,
It's 4 and 5.
no, it's one.
Curious.
No. They will go back once I do that. It sucks. Have you already done that?
No, I haven't done it.
So it's 4n and 4.
Sounds like water. Okay.
4n and 1.
It's also like, you know how teenagers are the best, that if they do something embarrassing, like recovering immediately and then pretending like nothing happened, like a freshman lost something and then dashed it around the corner. There was no water on the floor.
Because 4 times 1 is 4 and 4 plus 1. Okay.
Yeah, I'm right.
Yeah.
5 and on the bottom.
Yeah.
Everybody's working right now on the problem. You can fast forward until my pen starts moving again. All right, so the reason why is because my document camera has its own light. And so because it is, it's like they're talking back and forth. So the light adjusts right here, adjusts according to how much light is in the room. So when it brightens up, then my smart board brightens up because the light just turned on, and then it's like, oh, it's so bright in here, I'll turn down. And then it turns down, then the smart board goes down, and it's like, oh, it's too dark in here, and it lightens up again. It did not happen when I used to just have a projector projecting on my board, only when they put a smart board in here. Which, by the way, I said I didn't want a smart board for like a long time, and then I came in one summer and I just had one. So, suppose I could actually, like, I think smart boards are really helpful for teaching math, especially in middle school, for dragging stuff and geometry. You know how geometry, like, it's like great to like draw